In this section we'll have a look at signed numbers, signed or directed numbers. They are numbers that have a sign attached to them, positive or a negative sign. They're used widely, not only in algebra but in other sections of mathematics. Let's have a look. We got signed or directed numbers. They are numbers that are positive or negative, and they are opposite then. For instance, I've got an example here. Plus 25 means 25, or could mean 25 degrees above 0. And if you then talk about negative 25, it represents 25 degrees below 0. Won't happen, of course, in Australia. Notice that we write sometimes the number without the plus sign. It can be a bit confusing. Actually, it happens with the negative sign as well. We'll now have a look at some other examples of opposites. It's not necessarily temperatures. You could have, for instance, let's have a look, $25 deposited, $25 withdrawn. You could go 25 kilometers per hour faster, 25 kilometers per hour slower. See, they're all opposites. One is positive, the other one is negative. 25 kilometers north, 25 kilometers south. 25 kilograms gained, 25 kilograms lost, etc., etc. You can talk about golf as well. 25 above par, 25 below par. See, there are many problems where we deal with these particular positive and negative values. Now, let's have a look how we can add these signed numbers. There are some rules also for subtraction and multiplication and division, but let's first deal with addition. If we have two numbers and we want to add them, then really what we want is to find the total. Now, I've got an example here. Here it says, by the way, that we use that plus sign for both add and positive. But here's a situation where a person gains 5 kilograms and then loses 15. We say the overall effect is a loss of 10 kilograms. If you write that down symbolically, you write plus 5 plus negative 15 equals negative 10. So I've got that written down there again. Another situation may be that a person loses 5 kilograms and then loses another 15. The total effect is a loss of 20. Symbolically, here we go. It's negative 5 plus negative 15 equals negative 20. Now, there are some other cases, of course, and I've got those listed here. And you notice that every time that sign is the same, then the result there has that same sign. You see, the plus with the plus gives the plus, the negative with the negative is the negative. However, if one is a negative and the other one is a positive, then to get the result, you basically subtract the number from each other and you put the sign there of the one that is the largest one. And that indeed is the rule for addition of signed numbers. I've got that written down here. To add two signed numbers, what do? You add the actual numbers and you put the sign that is common in front. If they are different, you subtract and you put the sign of the largest in front. As usual, I've got a problem on the screen that illustrates this addition rule. Now, you will find that there are two methods really to do these additions. You can do what's called a successive method, or you can combine like terms first. Let's have a look at this problem. We've got add positive 27, negative 16, positive 3, and negative 5. Now, I've written them down there with brackets around them. And here we go. We've got the positive 27 and negative 16 successively. That is going from left to right as positive 11. That 3 is still there. That negative 5 is still there. Then I combine 11 and 3 to 14, and I finally get my answer. To do it the other way, that's called adding by sign. You look at the positives first, and there are 27 there and 3 there, so that makes 30 positives. And then we've got 16 and 5, that's 21 negatives. Combining those together, that gives you positive 9. Now, there is a rule, of course, for subtracting signed numbers as well, and that's what we're going to talk about now. Let's have a look at an illustration example. Subtraction is really taking or finding the difference between two numbers to find the change from one to the other. That's another word for subtraction. And again, as with the positive sign, here the negative sign is also used for negative. So that sign stands for subtract and negative. That makes it a little bit difficult sometimes. But here's an example. We've got the temperature changing from 5 degrees below zero to 15 degrees above zero. There's been a rise of 20 degrees. That's pretty obvious. How do we write that down? Positive 15, subtract negative 5 equals positive 20. It's a 20 degree change. So I've got that written here. Some other examples. If the temperature changes from 5 degrees above to 15 below, again, there's been a fall of 20. So I would write that symbolically as it was negative 15, but now it was originally positive 5, so I take that away from the negative 15 and I find a negative 20. We see some other examples there on the screen, and from that you can actually develop a rule. And in fact, the rule for subtraction is basically the same as for addition, because subtraction can be defined as adding the opposite. So if I'm adding a negative, or when I'm subtracting a negative, it's the same as adding a positive. Illustrated here. Here's the rule, because I can write positive 15, subtract negative 5 equals positive 20 as, well, the same result I would get if I add positive 5. So you can see that subtraction can be changed into addition, but then you have to adjust the sign from a negative to a positive. And in fact, that is the rule. Here we go. To subtract a signed number, add its opposite. Let's have a look straight away at an example. Subtract negative 7 from positive 9 first of all. So I've got the positive 19 and I subtract negative 7. So subtracting, adding the opposite. So that negative will become a positive, and that will be adding, and the negative 7 becomes a positive 7. And the answer we're going to get then is positive 26. This one, number B, can be done successively, and you get, in this case, positive 8, and I change the subtract negative 12 to an add positive 12, the subtract positive 3 to an add negative 3. Yeah, it's quite difficult. And in the end you get positive 12. Quite a difficult process. We can combine that, of course, and we certainly shall do that. Let's have a look at multiplication. That is a little easier, multiplication of signed numbers. We've got a situation where a person might spend $10 a day for 5 days, and it's quite obvious that he has $50 less. If you write that symbolically, then we have positive 5 multiplied by negative 10, because that's what he's spending, so we can call that a negative, is negative 50. If a person spends $10 a day, then 5 days ago he had $50 more. And if we write that down symbolically, 5 days ago as negative 5, and that spending of negative 10, and again we get positive 50. And so you see from there that we get a rule. And because there's some other examples there, positive 5 times positive 10 is positive 50, and negative 5 times positive 10 is negative 50. So you see from that there's a rule developing. If these signs are the same, then, well, that's in this example there. If they are the same, you get a positive answer. If they are opposite, then you get a negative answer. And that's what the rule is about. It's the rule of multiplication. If two numbers have the same sign, you'll find that their product will be positive. If not, their product will be negative. The rule is on the screen. There we go. The same sign, the product is positive. Different sign, the product is negative. You will find that the rule for division is exactly the same as for multiplication, because division is actually multiplying something by the inverse. Got that written down? Dividing two signs, see, if you divide 50 by 2, that's the same as multiplying by and half. You both get 25. And so the rule for division would be the same, wouldn't it? And here it is. If you have two signed numbers and they have the same sign, the quotient, that's the fancy word for dividing, is positive, and the different signs, if they have different signs, then the quotient is negative. Now it's time for an example using both the multiplication and division. Here we've got a complex looking problem, negative 2 times negative 8 divided by positive 4. don't really have to worry about the rules of order too much. You'll find the process of multiplication and division to be the same. You can do it in either order. I've done it. First the multiplication. Negative 2 times negative 8 is positive 16. Then we divide by positive 4. We get positive 4. Now if you do it the other way, where you first divide the negative 8 by the positive 4, you end up with negative 2 times negative 2, which equals also positive 4. And of course you should get the same answer there no matter what you do. Multiplication and division are essentially the same process. Now, with signed numbers, what they generally do is they leave off the brackets. Make it a little bit more difficult. You can put the brackets in and then do your work. That's what I've done here. Example. Okay, here we've got a typical signed number problem without those brackets. We can actually put them in, like I said before. That is a positive 8. Subtract a positive 9, so that positive sign there is inserted. Subtract a positive 10 and add a positive 2. And then you've got the same rule as I've had before. Positive 10, subtract positive 19 equals the same as, because the subtraction becomes addition, and that positive sign becomes a negative sign. The answer is negative 9. A quick way, and that's how most people will do it after a bit of practice, they look at 8 and 2, add them up to give 10. A negative 9 and a negative 10 is a negative 19. Combine those two into a negative 9.